Is an ECM blower motor upgrade actually worth it? The answer is not hidden in the motor label.
It appears when we replay the same building load, through the same air system, and compare what reaches the air, not just what enters the wires.
Start with the baseline.
Many older residential and light commercial blowers use a permanent split capacitor, or PSC, induction motor. It may have several speed taps, but each mode is still a selected operating band. An ECM is different. EC line power is rectified to a DC bus, electronic switches commutate a permanent magnet motor, and the controller can regulate speed, torque, or airflow. So DC motor is convenient shorthand, and HVAC ECM normally still receives AC supply power. That architecture can reduce motor losses and make part load control easier.
But it does not guarantee a lower electric bill.
First, lock the comparison to the same delivered airflow, pressure, air density, filter condition, wheel, and operating mode.
A smaller input wattage paired with less airflow is not an efficiency win. Measure complete wire-to-wire performance at the real duty point.
Now replay 1 day of demand.
At peak heating or cooling, both blowers may need nearly full output.
During mild hours, a fixed-speed PSC may cycle or use a discrete tap.
A correctly integrated ECM can follow a lower command. This is where runtime distribution matters. Annual energy is the sum of input kilowatts in each load bin multiplied by the hours in that bin. There is no honest universal savings percentage. Here is the trap most upgrade videos miss.
Add a dirty filter and system resistance rises.
A PSC blower commonly loses airflow as static pressure increases, and its input power may even fall. A constant airflow ECM may raise speed and power to defend its programmed airflow until it reaches a control, current, or speed limit. That does not make the restriction disappear.
It can increase sound and energy while masking a maintenance problem. Constant torque and constant speed ECMs respond differently, so identify the control type before predicting behavior.
Next comes the retrofit gate. Matching the motor diameter is not enough.
Confirm supply voltage and frequency, phase, shaft and rotation, will fit, mounting, cooling, temperature, moisture, grounding, and protection. Then confirm the command interface, line voltage taps, a 24-volt equipment board, 0 to 10 volt, PWM, or a digital protocol are not interchangeable.
The harness and pinout must be verified, not guessed.
Also confirm whether the programmed profile is constant speed, constant torque, or constant airflow across every heating, cooling, and fan-only mode. Noise and reliability also need an installed comparison. Lower speed can reduce aerodynamic noise, but electronics, switching, mounting, and a forced speed increase against high resistance can add tonal or airflow noise. A PSC has a simple capacitor-based system with familiar service points. An ECM adds electronics that require appropriate protection from heat, moisture, poor power quality, and surges. Neither architecture is automatically quieter or more durable in every installation.
Now calculate the decision.
For each operating bin, subtract the proposed measured input power from the baseline, multiply by annual hours, and add the results. Multiply annual kilowatt-hour savings by the relevant energy rate, and include demand charges if they apply. Simple payback is the net installed premium divided by annual cost savings. If the old motor already needs replacement, compare the upgrade premium against the avoided baseline replacement, not the full ECM invoice. Test low, expected, and high runtime cases. The upgrade is usually strongest when annual hours are long, part load operation is substantial, the controls can actually reduce speed, the air system is not excessively restrictive, and commissioning confirms the required duty. It may be weak when runtime is short, operation is almost always at full load, controls or fit demand major rework, or the baseline is already an efficient AC motor with a well-matched VFD. Before and after installation, record airflow, static pressure, input watts, sound, filter condition, and every operating mode. That turns a motor swap into a verified system upgrade. The real answer is conditional. ECM can be worth it, but only when compatibility, load profile, and measured wire-to-wire performance agree.
Need a curve-based upgrade review?
Send Longwell the existing motor and blower data, required airflow and pressure, control signals, annual load hours, electricity rate, and installation envelope.